So in the next section, now what we're going to look at are additional techniques of integration, and most of these do involve trigonometry. So the first thing that we're going to look at is what happens if you have combinations of sine and cosine inside your integral. So a couple of things. If one of the powers is negative, and that's what these first two things say, numbers 1 and 2. If one of the powers on your cosine or sine is negative, you're going to take one of those powers out and then rewrite the rest of it. And the way that we rewrite is that we use sine squared x plus cosine squared x equals 1. So if I were trying to rewrite a cosine squared, I have that cosine squared x is 1 minus sine squared x. And if I were trying to rewrite a sine squared, I would have 1 minus cosine squared. So if one of the powers is odd, so if I had like cosine cubed or sine cubed or something like that, if I had one of those, I am going to take one of those out and save it because I'm going to use U substitution. Right, so if one of them is odd, that's what I'm going to do. Now if both of them are even, then we would use the next identity, which is down here, which you might have seen these when you took geometry, I'm not sure. But another way to write sine squared is 1 minus cosine of 2x over 2, and cosine squared is 1 plus cosine of 2x over 2. So then we would go back and use the original ones. But if you have an odd power, we're going to take one out, save it for later. If you have even powers, then we use the equations at the bottom. So let's start by looking at the integral of cosine cubed. So for sure this is an odd power. So what I'm going to do is I'm going to take one of those powers out and save it for later. So I'm going to rewrite this as cosine squared x times cosine x dx. So here is the cosine that I took out because I'm going to save it for later. Now what I'm going to do is I'm going to rewrite cosine squared. And if you remember what we did on the last one, the last slide, we had that cosine squared is the same as 1 minus sine squared. So I can rewrite this entire thing to be 1 minus sine squared of x times cosine of x. And this should be a multiplication symbol right here. So I have cosine squared times cosine, which we did, so we brought one of our powers out. Then I replaced the cosine squared with 1 minus sine squared. And now what I'm going to do is I'm going to use some U substitution. So my U is going to be sine x, which means that my du is cosine x dx. So I'm going to rewrite this entire thing. So here's my du. I have 1 minus u squared instead of 1 minus sine squared, and so I've reduced this down to 1 minus u squared du. Take the antiderivative. Antiderivative of 1 is u. Antiderivative of u squared is 1/3 u cubed, and then I will replace all those u's and go back to sines. So I have sine x minus 1/3 sine cubed x plus c. So whenever you have an odd power, it doesn't have to be on just one. If you have sine or cosine with an odd power, you're going to take out one of them, because that's going to be part of your du in the end. So like this one cosine that I took out, that ended up being part of my du, and then use U substitution. So in general, we try to go back and forth using the sine squared plus cosine squared equals 1, and that's what you want to kind of do. And you could use these two half-angle identities, which we also discussed. So you could use those, and that happens whenever you have an even power.